Good morning, my second period crew. Sorry that I couldn't get in there this morning. My son has to go to the doctor's, so I will be in later on. I'll be in after, like, right around the middle to end of third period. So, anybody that wants to see me later on in the day, feel free to come visit me. But I just couldn't get in there for your second period class. Doctor's appointments are not very lenient when it comes to teacher schedules. All right, so day 10, analyzing distribution differences, is what we're going to do today. Make sure that you have picked up a Regents exam. Your Regents exam that you picked up this morning, you should do questions 1 through 10, or I'm sorry, 1 through 15, multiple choice questions 1 through 15. And the homework for this, it's not real lengthy. So please make sure that you give it some attention, both of those with some attention. Now that APs and all that is over, we've got to step up with Algebra 2 again. All right, so we're going to read this opening exercise. And we're going to talk about analyzing distribution differences. You're given a coin which you assume is fair. So remember, a fair coin is one that the weight of the coin is evenly distributed between heads and tails. But there is a possibility that it is weighted to land on heads more often than tails. So this one is not weighted, or is not fair, probably. Given the probabilities below, how many heads in a row would convince you that the coin is in fact weighted? So if it's weighted, there's got to be a number that we use, hint, hint, to determine whether something's got some kind of unusual territory or unusual behavior. So if I flip the coin, what this means is I flip the coin once and I get a head. And I flip it twice and go, all right, well, maybe by chance I got 2 heads. I flip it 3 times and all right, now I've got 3 heads. Okay, so that is some behavior that is somewhat unusual. Getting to be that point. So what I'm gonna do is I'm gonna go through the lesson and then we're gonna come back to this and talk about what in our terms, what in our statistical terms for Algebra 2 would be considered unusual, an unusual percentage of heads. Okay, so let's start the lesson. And like I said, we're gonna come back. All right, so we've got exercise 1 through 3 here. We've got random assignments of computing the differences in the group means. So let's read. Lincoln conducts an experiment to determine if studying for an hour impacts the number of questions correct on the learner's permit test. He randomly assigns the students in his homeroom who have not yet taken the test for 2 groups. Randomly assigned, so it's going to probably be a good experiment. Although it is not 50. It's not 50 kids, but it's still randomly assigned. One group agrees to study for an hour before taking the permit test, while the other group agrees to take the test without studying. The number of questions each student answered correctly was noted and recorded. Note, there are a total of 20 questions on the test. Lincoln wishes to examine the claim that the studying yields a better test score. So here are the 20 student scores, okay? Here's all the 20 student scores. They have been ordered, they have been ordered from smallest to largest based on the number correct. For now, do not be concerned with which students received the hour of study time. Here is one random assignment of the test scores. Okay, so here's group A. So you randomly assigned a group, the number of kids to group A and a number of kids to group B. So there's 10 in each. There's 10 students here and 10 students here. Why is it important for Lincoln to randomly assign the students to the group? So we can say it reduces any bias. He's not picking the kids that he believes may study or not study. He's just randomly picking them. So that reduces that biasness. The other thing, too, is it is part, like I mentioned, it is part of a well-designed experiment. Okay? Now, calculate the mean for group A and for group B. So I'm going to be friendly to you and give you the mean for both. And I'm going to write it twice so we can see it. So for A, the mean is 17.2 when I put the data in my calculator. And the mean for B is 15.8. Okay, so there's the mean. That's the average number of correct for each group. Now, there's something called a diff. It's calculate the difference between the mean of group A and the mean of group B. That is calculate this. So we're going to do 17.2 minus 15.8. And the diff between the two groups, the difference between the two groups is 1.4. Average of 1.4 questions correct. Okay? All right, so let's flip it. Now, we're going to interpret the value of a diff. I told you there's not a lot of math in this one. So really you're just going to be doing some subtractions and interpreting them. All right? So, not hard. The statistic of interest that you care about is the difference between the mean scores of group A and the mean scores of group B, right? What we just did. For now, call the difference diff. Diff is equal, in this case, to group A minus group B. A new random assignment of the test scores was created. Explain what a positive diff value would mean in context. Not hard here, guys. A positive diff, for our example, means group, because it's positive, group A's average score is higher than group B's score. Not hard. Okay, what happens if it's a negative? What happens if it's a negative diff? Well, that probably means that group B's average score, I'm trying to write neat so that you can read my chicken scratch. Average score is higher than group A's scores, or average scores. Okay, and what if it is a diff value of 0? Okay, don't kill yourself on this one. You got it. Both groups have the same average score. All right, recall that one of the groups studied an hour before the learner's permit in hopes of getting more questions correct. If the treatment wasn't affected, what diff value would you expect to find between the groups' means? What would you think? So we would probably say if there's nothing, if studying didn't matter, then the diff would probably be 0, right? It would probably equal 0. Okay? And there's a little bit more to it than that, of course. All right, so to decide if the difference between the sample means is significant, okay, so there could be a situation where we just have a chance high difference, right? Just a chance occurrence where even the kids that studied or the kids that studied really did get significantly different than the ones that didn't study, okay? So in order to do this, Lincoln creates 100 different Group A, Group B random assignments and calculates the mean of the two groups and their differences. Yes, he's doing a random sample here. A random assignment, and then does it 100 times. The dot plot below displays the difference between the means of each of the 100 trials of the simulation. Okay, so there's 100 trials of this simulation. This dot plot will serve as a randomization distribution for the diff statistics. So he did it 100 times, and then he took the difference of the 100 times, and then he recorded it on a dot plot, basically. Okay? Now, this is where it becomes really important. All right? Really important. So these are the numbers right down below that you've got to make sure that you have. And it's right here. It says a sample difference is considered to be statistically significant. Okay, so it means that there's really some kind of aha thing that we should look at, like on our heads, our weighted heads in the front, that opening example. How do we know it's statistically significant, or it's just, yeah, we just got lucky and we got a bunch of heads? So a sample difference is considered to be statistically significant if the probability of the difference is extremely low under the assumption that there is no difference. Referring back to our opening exercise, once you get a probability of 5% or below, okay, so our key numbers here, our probability of 5% or below, we start to get into what we call unusual territory. In real world situations, the cutoff probability for unusual territory varies from situation to situation based on the context of the problem. But for our math purposes, for Algebra 2, we're always going to use the value of 5%. Okay, so if something is 5% or lower, we consider that to be very unusual territory. So there's a statistical significance there. Okay. So, given the distribution pictured above, that is based on the simulation results, determine the approximate probability of obtaining a diff value as listed below. So, use your 5% threshold. Would you consider the diff values below to be statistically significant, and explain? Okay. So, let's go to A. It says of 1.2 or below. So I'm going to come up here, and I'm going to go to 1.2 or more. That's what I should say. 1.2. Here's 1.2 or more. And I count my dots, just like I've done before with these, just to figure out a percentage. And I get 8 out of, remember, there are 100 dots there, which is 0.08, which is 8%. And I would say that is not really statistically significant, because, and I'd probably do it just like this, it's just not less than 5%, or you could say 8% is not less than 5% with a slash through it, or something like that, right? All right, what if we've got a difference of negative 2.4 or less? Negative 2.4. So if I get a difference of negative 2.4 or less, I counted 4 dots. 4 out of 100 produces a 4%, right? 4% of difference. So I would say yes if I have a negative 2.4 difference between my two groups. That is statistically significant. If diff is negative 2.4 or less, we're going to say statistically significant. Because 4% is less than 5%. Okay, what about for C? Within 0.4 of 0, including, that means including 0.4, by the way. So go on up and count within 0.4 of 0. And so the 0.4 is 0, and I found 37 when I did it. So that means 37%. We would say this is not really statistically significant. Not really statistically significant for ours. Okay, so that is when you go to do problems like this and they're asking you, the question is going to be, is it statistically significant, or does it make a difference, or they'll have you assess a multiple choice question and you got to look for that 5% or less. That's when you can say something about some type of statistical significance, or draw some kind of conclusion that is unusual. So when we go back to, this is all kind of done for our purposes here. Let's go back to our question on the Albany nexus. And I say to you, how many heads in a row would convince you that the coin is weighted? I would say that I would need 1, 2, 3, 4, 5 heads in a row for our purposes here, because this is unusual. The probability of getting 5 or more heads in a row is 3%, 1%, or 0%, right? That's the percentage. That's unusual because this is less than a 5% chance. Now, the ones we did in our examples were just taking differences of two groups. This is actually just a probability of flipping a coin. So if we have a confidence, now, and where does this, let me summarize for you. Where does that 5% come from? Well, if we have a confidence interval of 95%, right? There's 5% chance that's unusual territory. So because we have a confidence interval of 95% here, once we get to anything less than 5%, it is unusual. And so that's where we're going with that 5% for our purposes. For Algebra 2. Okay, so to summarize on the very back page, and I'm going to leave 9 for us to do another time. It says the rule is as follows. When the possibility of a difference is 5% or below, it is observed difference is extreme and not typical of chance behavior. It may be considered statistically significant and possibly not the result of chance behavior. So if the difference did not just happen by chance alone, then maybe the difference you observed is caused by treatment and by the treatment group. In the context of our studying example, a statistically significant difference value provides evidence that the studying did in fact cause higher test scores on average. Okay, so let me say that again. In the context of our studying example, a statistically significant diff value provides evidence that the studying did in fact cause higher test scores on average. Okay? All right, guys. Sorry that I wasn't there. I will be there later on. And hopefully this wasn't too daunting for you. And you can do the homework okay. And if you have any trouble, we'll go over it on Monday, but make sure it gets done. Okay? All right. Bye-bye.